This video is brought to you by this bearded gentleman, this Viking warrior with his double-headed axe. This is page 260. So we are finishing the simple interest formulas. And in this point, we're given different versions of things, and we're asked to find one missing thing. So here, some newly married couple made some investment of $15,250 for 10 years, and they received $9,150 in simple interest. The question is, what was the rate that the investment paid? All right, what we're going to do is identify the things we've been given. Note the word invested $12,250. That's the principal. That's the initial amount of money that has been deposited into some sort of account. We've got amount of time noted in 10 years, and then received $9,150 in simple interest. Notice this is a dollar amount and it says interest, so that's the I, not the rate. And then the question says, what was the rate? So what we're trying to find is rate. What we now need to identify is which formula are we going to use to solve for this. And when I look back at my options, I have A equals P plus BRT, and I have I equals PRT. I really have those two formulas. This one, we could also have P plus I, or the factored version. I don't often use that one. It's not, to me, it's not particularly useful. And if you notice, there are four things here with one unknown. This first equation, the simple interest formula, has four items in it. So we can use this equation to solve for our one unknown. Now, what we could do is plug all the things in. So I can put in I for I, 9,150, equals, I'll put in P for P, 15,250, times R, oops, I don't know that one, that's what I'm trying to solve for, times 10, and then we can do the algebra, multiply these things, divide, whatever. But you could also solve this equation for R directly and rewrite a new equation. So if I divide both sides by PT, I get that R equals I divided by PT, and I get a new formula solved for the interest rate. I could also solve this formula, say, for time. What if I wanted to know the time given the other three things? I would get I divided by, let's see, PR, and then the third one, what if I wanted to know the principal given the other three items? That's just I divided by, let's see, RT. So this one formula we can solve for the other three missing items, and we get like three versions of it. And if you're not a big fan of algebra, I'd say use those and just plug and chug. So doing that, I'll take this formula and say, well, my R is equal to, well, I is 9,150 divided by principal times time. So that's the 15,250 times 10. Well, of course, we scamper off to Desmo, so why do anything in our heads? That's silly. I like to do things in the fraction, so I just hit the division sign right off the bat. So here's my division sign. In here, you can also just hit division on your keyboard, and then type our MSN, and we get 0.06. Note that's the decimal version of the interest rate, so if we want to turn that into a percentage, multiply it by 100, and there's the percent. This married couple was earning 6% interest. So I'll write that down. It was not approximate, it was exact. Times 100, we got a 6% interest rate. This was simple interest per year. All right, question 2 is a similar riff, and we're probably going to be asked to use one of these versions of that simple interest formula. So note here they're saying if the couple had to find an investment that paid 9% interest, how much more quickly would they have made that $9,150 in simple interest? Notice we are to assume that they invested the same amount. So we're still investing the $15,250. This time we're asked what is the time? How much more quickly would they have earned? It's implied here that this represents time, an unknown amount. The rate has changed now from 6% to 9% per year. That would be 0.09 as a decimal. And then our interest rate is, or our amount of interest earned, oops, I don't know why I put a T there, would be 9,150. Well, if we look back at the equations we wrote down before, we have a solved for equation. Time equals interest divided by principal times rate. I'm going to use that one to calculate how much more quickly. Well, not how much more quickly. Oops, wrote down the wrong one. I'm going to use this one to figure out how much time it's going to take to earn the 9,000, and then we'll subtract it from the amount of the 10 years from the prior one. So time is equal to the interest rate divided by the principal times the rate. So the interest divided by principal times rate. The interest was 9,150 divided by the principal, 15,250 times, in this case, 0.09. All right, scamper over to Desmos. I hit my division symbol, 9150, 15,250 times 0.09. Okay, it's 0.66666666 forever and ever and ever. We can round that to, I don't know, what, 6.7 years? And then recall that the previous one took 10 years. I have that still here sitting in our deal. So the difference between the two is the 10 minus the 6.7. Of course, if I type it in right, we'll get it right. There we go. So it's 3.3 years faster. That's what's happening for this particular, or that's the answer we're looking for. So 3.3 years faster. All right, the final question in this section is leading us into the concept of compound interest. So here we're saying, let's say that you invest $1,000 into a simple interest account at 3% per year. And by that simple interest formula, you do 1,000 times 0.03 times 1, you'd get $30. Hooray. So at the end of that year, you'd have 1,030 in your account. Well, the next year we just get $30 for that simple interest. But what if instead we pulled all the money out and then redeposited it in the second year, and we then earned 1,000? We earned 3% interest on the 1,030. In other words, you get paid interest on the $30, but that's not what question 3 says. Question 3 says, forget about the original amount and just think about the 1030 in your account at the end of year 1 as a new investment. If you get $30 in interest over the next year, what percent did you actually get? We're supposed to show our work. Remember that one way to calculate a percent is that is a part divided by the whole. So in this case, the part we're looking at is the $30. And the whole we're talking about is the account balance of 1030. So if we're not paid the 3%, like we're not in simple interest, off of the 1030, we're still paying it off at 30. What percentage does this end up being? So let's scamper over to Desmos. 30 divided by 1030. Ooh, that's approximately equal to 0.029126, etc., etc. Remember, if we want to convert that to a percentage, we'd multiply by 100. So that is coming out to about 2.91%. So by not redepositing that into the account, by not earning 3% on 1030, we're missing out on, let's see, 3% minus 2.91%. Ooh, that's 0.09% of interest. That's what we're missing out on. That's what the compound interest starts working for us. Oops, that was supposed to do that in number 4. So if you'd actually been paid the full 3% on your 1030, how much more interest would you have earned? Well, really on this one, we're going to say, what's 3% of 1030? Well, let's gamble back to that. 1030 times 0.03. Oops. There we go. We should have gotten $30.90. So if I subtract from that the 30 we were actually given, oh, we're missing out on 90 cents worth of interest at the end of that first year because of, or the end of the second year, because of that simple interest that's happening. Okay, question 5. How much interest would you have earned in the third year if you get 3% on the new amount again? All right, this one's getting a little crazy. So if this was the year 2 interest that we were supposed to get, the account balance at the end of year 2 would have been the 1030 plus that $30.90. So we would have had $1,060.90 at the end of year 2. So for year 3, we would be looking at 3% of that amount. That's how much interest we should have earned for the full year 3. Well, what does that turn out to be? 1060.90 times 0.03. Ooh, we now should have had $31 and what, shall we say 83 cents, because they're not going to give us 0.7 of a cent. So by the end of the third year, if I subtract away what the simple interest would have given us, we're missing out $1.83 in interest after 3 years. This is where compound interest gains its power. And we're going to see compound interest take shape in Unit 3 too.